Okay, going over quadratic function here. They've given us this function. I wish I could hide the bottom of this, but anyways, it's almost in standard form. The only thing is they really haven't combined our two middle terms to make a b. Okay. What they've done is also known as decomposition factoring. This is usually the second step to decomposition. You split the b. Now in decomposition, in order to split it, what you're looking for is two terms that are going to add up. So two terms that add up to our b function. And those two same terms are also going to multiply to whatever a times c is. Now in our case, our a term is our 4 and our c term is our 1. So those two numbers need to multiply to the number 4, positive 4 in this case. So we jump down a little, and we filled some things in. A times c was 4, so we replaced it. So we were looking for two terms that multiplied to 4, and those same two terms are going to add up to our b. But in this case, our b is actually negative 3 plus 2k because we don't exactly know what that number is. Now it turns out for factors of 4, we know there's 1, 4, 2, and 2, right? And we also have the positive and negative versions of each. Positive 4 times positive 4, negative 1, positive 1 times positive 4, negative 1 times negative 4, both give us a positive answer. And same with the 2's. So I have 4 options for answers here. So with those 4 options, I figured out what each of them added up to because I knew that's what this bracket was going to need to be. I knew that this bracket needed to be in one of the options equal to 1 plus 4, which is 5. So I kind of jump down. 2k minus 3 equals 5. A different option was also negative 1 plus negative 4, which was negative 5. So I set that equal to 2k minus 3, negative 5. The other option is 2 plus 2 and negative 2 plus negative 2, which gives me positive and negative 4. So I set up equations with 2x minus 3 equals 5 and equals negative 5 equals negative 4 and equals 4. And I got 4 different values for k. Once I got these values for k, I plugged them into this formula here, which is the original formula they gave us, to find out what the standard form of each of these would be. Okay? So we always knew that our first term was going to be 4x squared, and the last term was going to be our c, which is going to be 1. But when I put in different values for our k, I got different b values in each of the equations. For the very first one, when k was 4, that gave me 2 multiplied by the number 4, which gives me 8. So I was working with negative 3x plus 8x, which gives me positive 5, which was my first option here for b. I then plugged in k at negative 1. Well, that gave me 2 times negative 1, which gives me negative 2. So I was working with negative 3x minus 2x, which gives me negative 5 as my b term. So I'm now working with 2 separate quadratic functions, different b terms. Okay? Now, before I move on to the next two, the question asks us to figure out the proper equation when there be 2 zeros. Now, instead of going through the entire quadratic formula and trying to figure out if there's 2 zeros, I used a little formula called the discriminant. The discriminant is b squared minus 4ac. And if you remember, that's actually what's underneath the root in the quadratic formula. The reason it's underneath the root and why these values make sense, I'm going to explain right now. In order to have 2 zeros, I need b squared minus 4ac to be greater than the number 0, or in other words, positive. Because I can always find the square root of some positive number, call it z. And if I can find the square root, I know I can keep going in the quadratic formula, and I'll eventually get 2 zeros. If the discriminant is equal to 0, well then I'm looking for the square root of essentially 0, which is just 0 itself. So that's only going to give me 1 root. Because when I square root 0, I'll only get one answer, being 0. And the final answer, our final option is if the discriminant is less than 0. So I'm looking for some essentially negative number. I can't find the square root of a negative number. Therefore, there are no zeros. There will not be any x-intercepts. So once I got these formulas, the quadratics, I plug them into the discriminant. if I got what I was looking for is options when it was positive. So I solved for the first two, k equals 4 and k equals -1. I still had to get 2 more after that. In the first set, I plugged these values for a, b, and c for the discriminant. We got b, which was our 5 squared, minus 4 times 4 times 1, which gave me 25, minus 16 gave me 9. So that does have 2 zeros, that option. The other option, I put -5 in for the b, and times -4 times 4 times 1 gives me 25 minus 16. Again, positive 9. So both of those options had 2 zeros. The next thing I figured out was when k was 7/2 and when k was -1.5. I solved for their trinomials. I'll go quickly up and show you how I did that. When k was 7/2, I multiplied by 2. The 2's cancel each other out. And I'm left with -3x plus 7x, which gives me positive 4x. That was what this b was right here. And then when k is -1/2. When k is -1/2, I multiply him by 2. The 2's cancel out. I'm left with -1. So 3x minus 1x, which gives me -4x as my b value. So that's what I got over here. I'm now going to take these values and plug them into the discriminant formula. Now remember again, d is equal to b squared. My b value is 4, and in this one it's -4. A values are still 4, and the c values are still 1. So b squared gives me 4 squared minus 4 times a, which is 4, times 1. 4 squared is 16. -4 times 4 is -16 times 1 is -16. So my discriminant is equal to 0. If my discriminant is 0, that means I only have one x-intercept, or 1, 0. So this is not an option. This won't work for us. And as you can imagine, we're probably going to end up with the exact same thing over here. -4 squared minus 4 times 4 times 1 is going to give me 16 minus 16. I know it's lagging a little, which will give me 0 again. Again, something that doesn't work. So I was only able to come up with 2 answers here. They wanted us to know the k values. The k values that worked, when we jump back up to our answers, this guy did not work and this guy did not work. He worked and he worked. So k value of 4 or -1 gave us answers that had 2 zeros or 2 x-intercepts in the end. Okay, let's try another one where they're looking for the value of k, or what we commonly know as c. Right? One of the ways of factoring we talked about is where you find 2 terms that are going to multiply to a times c. Okay, so they multiply to a, multiplied to our c term. Those same 2 terms need to add up to our b term, which is right here, -4. So we're going to plug in some values for there. We're also going to give values to our missing things. We're going to call them, in this case, well, there's already an x involved in this and a y, so let's call them n and m. Okay? So I know m times m, n times m, oh, that's hard to say. Let's go with no. Alright, just so it's a little easier to say. N times o is going to equal that. O looks like 0. I need better ones. N-E. E is actually a term in math. Brutal. Let me pause this for a second. Okay, after much deliberation, we've come up with the variable n times l and n till cursive l. Alright, we can plug values in for b. We know b is actually equal to -4, so in this case, I can rewrite this as n plus l is equal to -4. Okay. I can also rewrite that n times l is equal to 3k. Since that's what our c value is k, we get 3k. Okay. Also, the restriction on this is they wanted a value of k that had one x-intercept. So, remember we talked about we had a discriminative formula, b squared minus 4ac, right? Well, that this value actually needs to be equal exactly to 0 because we need the discriminant to be 0 to only have one x-intercept. Now we actually know values of b, a, and c. A value of b here is going to be -4. Our value of a is going to be 3. And our value of c is going to be our k value. Okay. So our discriminant, our final formula here we can write in is 0 is equal to -4 squared minus 4 times 3 times k, which I can simplify. I can write it to 0 is equal to 16 minus 12k. Alright, so I have now 1, 2, 3 formulas, and I have n, l, and k, 3 variables. As long as I have the amount of formulas, I can work backwards in solving this through substitution and elimination, which is stuff we would have went through in grade 9. Now what I'm going to want to do here is I'm actually going to want to take this equation here because it only has the 2 variables involved in it, right? N and L. And I'm going to set this equal to either N or L because N and L are both involved in this one, which has a K, and this one only has a K. So I want to come up with some value of K in this. So let's say we get something like K or L is equal to, let's rearrange formula 2. Formula 2. N, let's say L equals -4 minus N. Okay, I now have a value for L. L can be substituted with that. So formula 1 now. I can now substitute in for the L in that formula. N times -4 minus N is equal to 3k. Well, I can simplify what's here. 3k, and I have my distributive property. I distribute the n into both of these. I would get -4n minus n squared in this case. Okay. This is technically a quadratic. Okay, and it's a quadratic, which is there's a difference of squares divided by 3. Let's come over and let's factor out a -1. Or actually, you know what? Let's just rearrange this. -n squared minus 4n is equal to 3k. Now I can choose to set this equal to just k itself and plug values in, but then I'm going to be working with n values equal 0. Yeah, okay, let's do that. I want to set this equal to k. The reason I want to set this equal to just k by itself is because there is a k in this formula that is equal to 0, which means I can factor or use a quadratic formula to solve for an answer. So, after deliberation, we discover that k is equal to -n squared divided by 3 minus 4 divided by 3n. Does that make sense to you? I divided both sides of the equation by 3. So I now have a k value that is that, and I can substitute it into equation 3. So equation 3, we get 0 is equal to 16 subtract 12 times -n squared divided by 3 minus 4 divided by 3n. Again, we have to work with our distributive property here. Now both of these are negative answers, and we're multiplying by a negative number. Let's zoom in a little so we can see this a little better. Right? So I'm going to end up with positive answers once I use my distributive property. I'm going to get 0 is equal to 16 plus 12n squared over 3 plus 48n over 3. Now these are actually going to work out into round numbers for us. We're going to work out into 0 is equal to, and we're going to rearrange this. What's 12 divided by 3? 4. 4n squared. 48 divided by 3? 16n. And plus 16. Now that I've done this, I can solve for n. I've set up a quadratic formula, and we know how to solve quadratic formulas. So the goal was to get to here, to have one variable set equal to 0. Because it's set equal to 0, I can put this in the quadratic formula, or I can factor to give me answers for n. So, answers for n. I can take the greatest common factor out first. Do you know what the greatest common factor is here? 4. 4 comes out. We're left with n squared plus 4n plus 4. This 4 can kind of drop off. I want to work on factoring this or putting it into the quadratic formula. Either will work, or we put this one into the quadratic formula. But let's see if we can factor this. The values of n, or the factors of n are n and n, or 1n and 1n. Factors of 4 are 4 and 1 and 2 and 2. And we know they need to add up to what number? 4n. Wow. Quickly looking at this, we're definitely using the 2's. 2n and 2n will add up to 4. This works out very nicely. We're going to be left with 0 is equal to 4 bracket n plus 2, n plus 2, which are the exact same. So we're actually going to end up with one answer here. I have to set both of these equal to 0. We split the equation, so I get 0 is equal to n plus 2, and redundant, but just for process sake, 0 is equal to n plus 2. So n is equal to negative 2. That's what we've discovered in this question. Now, this is very important because we've solved for one variable, which means I jump all the way back up to the start. I now know that n is equal to, what did I say? Negative 2, correct? So if n is negative 2, I look at formula number 2. If n is negative 2, I can solve for L. Let's take that formula down. Which one was that again? Formula 1? No, that was formula 2, which said n plus L equaled negative 4. Well, we now know that n is negative 2. So we get negative 2 plus L equals negative 4, which means L is equal to what? Negative 4 plus 2, which is just negative 2 again. So look at that. N and L end up being the exact same answer. L is negative 2. Jump up one more time. Our formula 1 has an n involved, an L involved, and a k. And k is the goal. Finding out what k is. So, I'm going to bring formula 1 back down here and actually solve it. Formula 1 now. In this one, we know that n equals negative 2. I'm going to say L and n equal negative 2. The formula stated that L times n equaled 3k. Well, since L and n are both negative 2, 3k is equal to positive 4. K is equal to 4 over 3 as a value. Again, pretty in-depth as a final answer. Okay, after showing you a redundant, super hard way to solve this, I can't believe I didn't think of this the fast way. Discriminant. We need to have one 0, so that means the discriminant needs to be 0. Discriminant formula is b minus 4ac. Stands for discriminant. If the discriminant d needs to equal 0 in this case, we plug 0 in, and we plug in our values of b, which is negative 4 squared, minus 4, and a, which is 3. And we solve for c, because c is our k value. So I turn that into a k. I'm now left with 0 equals 16 minus 12k. I bring 16 to the other side. Negative 16 is equal to negative 12k. I divide both sides by negative 12. K equals 4 over 3. All right, let's go back to that first question and see if we can solve it just as quickly. In that question, it said the discriminant, they need to have two zeros. So in other words, D needed to be greater than 0. Okay. So in other words, when I write my discriminative formula, I'm going to get 0 is less than b squared minus 4ac. And I'm going to plug values in. Now this one will be a little more complex. Our b is technically negative 3 plus 2k. So I get negative 3 plus 2k squared minus 4 times our a value is 4 and our c value is 1. 0 needs to be greater than negative 3 plus 2k squared minus 16. Okay. I'm going to need to FOIL this to bring it all out. 0 is less than, when we do go to FOIL this, we're going to get 4k squared. I'm going to quickly do it on the side here. Negative 3 plus 2k, negative 3, 2k. Okay, so when you do go to FOIL this, 3 by 3 gives us 9, 3 by 2 gives us negative 6k, 2 by negative 3, negative 6k, and 2 by 2 gives us 4k squared. So I just rewrite it, 4k squared minus 12k plus 9 minus 16. I just have to combine the brackets here, so we get 4k squared minus 12k. 9 plus 16 will give us negative 7. So I'm now left with, again, a quadratic equation. Because I have a quadratic equation, I'm going to use quadratic formula or factoring to solve this. Okay? We can quickly check if there's any factors, which will be 1 and 4, 2 and 2 for the first one, and 1 and 7. They need to add up to negative 12. If we do 4 by 1, no. Oh, 2 by 7 and 2 by 1 will give me 14 and 2. And if the 7's negative, the 14's negative. Does that make sense? Yes. So, I know that this pairing and this pairing will work. So, again, still 0 needs to be greater than, we set up our brackets, 2k minus 7 and 2k plus 1. Well, both of these, again, we split. The only difference is we're not using an equal sign. The equation needs to be greater than 2k minus 7, right? And 0, again, needs to be less than 2k plus 1. So we're looking for two different values here. When I move 7 over, I'm going to get 7 is greater than 2k, and negative 1, sorry, is less than 2k. And then we're going to get, we need values of k that are greater than 7 over 2 or greater than a half when we did this. Okay. They need to be greater than those two values. So when we did look for values of that, there are many different options. One of the ones we found in the first answer were 4 and, yeah. If we were to draw this on a number line, if we were to draw this on a quick number line, we're looking for values like this. Negative a half, 7 over 2. Right now. This should have been a negative, which means there's a rule when you divide by a negative for inequalities, it flips the sign. Do you remember that at all? Have you ever seen that? Yeah. So, what that means is you should actually have a value that needs to be less than negative a half. And what they're talking about there when they say that is you need less than a half or greater than 7 over 2. Any values in here won't work for our answer. Okay. You couldn't be greater than this and greater than this, because then it would just be greater than the smaller one. So it has to be going opposite ways, or they have to be greater and less than this way, so or in between here. Those are the only options when you're talking about number lines for restrictions